Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in today's video we're going to actually get back to a little bit of tool making. For some time I've been wanting to come up with some way to hold round material here in my mill vise. A lot of times I'll have something like a thin round piece, and to try to hold that in, even setting it on a parallel, you still only got the two contact points. And oftentimes what I've wanted to work on is a piece similar to this, where I've turned this is just out of the scrap bin, but say I've turned the boss on the mill or on the lathe and then parted it off. And of course the parting off might not always be flat, so I'd want some way to hold that in, maybe down on that boss shoulder. Let me grab a parallel right quick. You set a parallel across the vise and put a V-block on, but in cases like this, the V-block is too high, and if I held this in, again the V-block is too high to get to this top surface. Now what I've first thought about doing was, this is an orphan V-block here. I don't have a match to it. It was in a box of stuff, shop made. JK made this. Nice V-block, but I thought about cutting it off to the height of the vise jaws minus the thickness of a parallel that it's sitting on. But this is very, very hard. I could grind it off, I guess, cut it off with a grinder and then polish it on the surface grinder. But not too long ago, Tom Lipton over at Ox Tools posted a video. I'll try to remember to put a card up here. Yeah, try to remember to put a card up here to that link to his video to check it out. Here's a picture of during the process of making it in his video that I did a screen capture of, so you can get an idea of what he was making there. And that is exactly what I want to do here on my mill as well. But currently I don't have any material thick enough to make those pyramids or triangles on. So I'm going to try something a little bit different. You know, I got the name Pragmatic for a reason. What I'm going to do is take this piece of 3/8 by 2-inch material, mill it down. I'll mill it down first to within about 20 thousandths of the height of the jaw. I've already got it cut to length within about probably 200 thousandths of the length, but we'll clean that up, mill it down, then carry it over to the surface grinder, remove any mill scale that may be under this orange paint that's on here, get it squared up and get it right for the back. Then what I'm going to do is take a couple pieces of short pipe and attach it to this flat piece. Now what that will give me, very rough drawing here, what it'll give is two contact points like you would have on a V-block. Then there'll be a couple holes in this to attach this back to the vise jaw. Now if you were just going to do one piece of whatever you were working on, it wouldn't be necessary to attach this. You just put it in there, find the center of the round piece, do whatever you need to do to it, and be done. But doing multiple pieces, you don't want this moving in either direction. Of course, you could try lining up, but I think the first thing we're going to do in this project is remove this jaw, and these screws that mount the jaw to the vise we're going to carry those over to the lathe and drill and tap the center of them for a 1032 uh, socket head cap screw. And then that can be used to go through this piece and mount it too. So let me get this jaw off right quick. I don't know, y'all. They may be hardened. Oh no. Just didn't have the center drill in there good and tight. So now we'll put our tap drill for 1032. And I don't see any reason not to drill this all the way through. That way I'm not dealing with a blind hole. I'll try a little more RPM. Now we're going to use our 1032 spiral, 2-flute spiral tap. All right, we have one of them drilled and tapped. I'm going to do the same thing to the other one, and we'll be right back. All right, both of our jaw bolts are drilled and tapped on the inside now. And of course, again, that'll be used to hold that V-jaw up against the existing jaw. While we're over here at the lathe, we've got a piece of 1/2-inch black pipe in the lathe. I'm going to turn this down to a nominal value. Right now it's about 850 thousandths for the outside diameter. Probably turn it down to 840 if that cleans it up, which I don't think it probably will, but may get it down to 825, something like that. And then we'll cut 2 pieces that are the same as the height of the jaw. So I've got a counterbore tool in there now. I'm going to use that just to clean up the inside of the pipe, but I think first what I'll do is actually face that end off. Now we'll clean out the end of that board just a little bit. All right, that's not quite cleaning it up, so that was 20 thousandths. It's 821 thousandths. I'm just going to take another 20 thousandths just to make it 800. Again, this is nothing critical as far as dimension. It's just I would like to have a nominal value. All right, our jaw height is 1.448, 1.45 we'll call it. All right, I think I want to make these about 20 thousandths over that, so 1.465. We want to leave a little room for surface grinding. All right, I'll set the Z-axis DRO right there, and we said we wanted 1.465. I'll lock the carriage down right there, and also tighten the compound just a little. Now for a sanity check. It looks like just a little over, which should be 20 thousandths over. All right, I suspect that little fella's going to be hot. After it cools off, we'll turn it around and clean out the inside of that like we did the other end. All right, so let's face this one off. All right, I think we're done now with the two pipe pieces. Again, I'm going to let them cool off, and then I'll put them back in here, and off camera I'll just run the countersink in them just to clean them up a little bit. Again, this is 1/2 inch black steel pipe. I'm not going to bolt this jaw back in place just yet. Reason being, I just had a thought that I might need to check this distance here for the center of the bolt. And this bolt pattern here is not on center. There's 100 thousandths difference between here and here. So what I want to do is transfer these, transfer punch these holes onto this piece after I get it dressed up into size. So I'm going to put a couple parallels in. First thing we're going to do is get this to length. I'll clean up one end, turn it around, clean up the other end, take a measurement, and see how much we need to take off. Okay, now that I've got that end, both ends cleaned up, my target width is 4.270. I'll double check that right quick. Yep. I'm currently at 4.432, and we'll start whittling that down. 4.273. I was shooting for 4.270. 3 thousandths is perfectly fine for that. So what I'm going to do now, clean up some chips. Then I'm going to stand this up, get a flat edge, get a flat surface on one edge, flip it over, and then rough mill it down to the height of the jaw. To do that, I'm going to use a roughing end mill instead of this finishing one. That way what we'll do is make the finishing cuts over on the surface grinder. Okay, I got the piece flipped over now, and I've got a rough mark here of the depth. Again, we're going to finish this up on the surface grinder, but I've got it sitting on a parallel now. Got it clamped in there, and we got about 444 thousandths, 450 thousandths to take off of there. That's just a very rough measurement. So we're going to try 150 thousandths at the time depth with this rough and end mill and just see how it does. That might be just a little bit extra being left there, but again, we can clean this up on the surface grinder. All right, I think I need to carry this over to the belt grinder right quick and just clean up some of these edges and then get set up on the surface grinder. So I'll meet you over there. Over here at the surface grinder now, and before I start grinding for the height, I'm going to surface grind the two flat surfaces to get the paint off of it and any mill scale. Now, while I was over there on the mill, I actually happened to notice that this piece is a little bit concave. Not sure, concave on this side, convex over here. Not sure if you can see that. But what this was a support arm on a piece of farm equipment. And I got to looking, and you see that? See if I can get it just right. See that line through there? I think this was put in a press, and that bend was put in there intentionally. As I say, it was a support arm, and I think that was probably put in there to limit bending. But this is the only material I've got in the shop right now, so we're going to make it work. This thickness really don't matter other than having enough thickness to countersink a screw in. So I went over to the belt sander and cleaned off a surface on the convex side. So I'm going to put that down on the surface grinder. Then grind this just enough to get it flat, flip it over, and do the same thing on the other side. This brass screw right here, if I loosen that, then this wheel turns for the coarse feed. Tightening it down, then this one allows, and this is the Harry Super 612. I've seen lots of them that doesn't have this one, doesn't have the fine feed on it, but you can actually adjust it to 1/10 of a thousandth. So what I'm going to do here is, there's 1, 2, 3 thousandths. So we've got a good flat surface there. Now what I want to do is, of course, clean the chuck off. Now what I'm going to do is take this surface that we just ground, put it down. It should set flat. And there's the cleanup of the other side. As you can see, there's one little area right there where that knife pushed down on it in the press to put that curvature in it. We want to set this up on the edge and clean the edges off, but that's not a very stable. Get that grid off of there. This wouldn't be very stable. So what I have are what's called some magnetic transfer blocks. These are made like a chuck is made. So what I'm going to do is put one of these down on the back. Well, to give you an idea, there's with no support, and you see I can pull that off. I'm going to set this at a little bit of an angle as well to keep from pushing directly across from it. But I'll put a magnetic transfer block on that side. I believe these are, yeah, they're a little bit too wide to stand up. Now with that sandwiched in between, I can still push it a little bit in between. That's why I've got it turned at an angle some. So now we're going to just clean this edge up, just whatever it takes to clean that edge up. Then we'll flip it over and grind it to height. We're looking 1.45, and that's 1.52. So we got right much grinding to do on the other edge. And this late in the day, I don't trust my in-brain math skills. So here we're reading 1.522, 1.522 minus 1.450. At 72 thousandths, we'll need to come down. So that'll be a full turn and then 22 thousandths. So that's going to take a little while. I'm going to do that, and then I'll bring you back when when I'm getting ready to make the final pass on here. Okay, I changed my setup just a little bit. Instead of having this at a diagonal with two of the transfer blocks, one on each side, I decided I would put it perpendicular or in line with the wheel to make each stroke count a whole lot more. I didn't have to step over but 3 or 4 times versus 25 or 30 times. But what I did was take one of the transfer blocks and put it at the end. Again, any force would be over here to hit this stop plate if something was to fly off. But this has held it. I've got, of those 70-some thousand, I'm down to needing 6 more thousandths off. So again, I'm going to come up here and zero out the big wheel. And we're going to take about 6 more thousandths off, and then we'll be plenty close enough to being the same as the jaw height.